Okay, so tuloy tayo. Dito tayo nagtapos kanina. So ito na yung next slide. Makita natin dito ang underground duct bank, mga conduit, PVC conduit na kinakabit, no? At siyempre lalagyan dito ng mga manholes, no? Ngayon ang ating reminder dito pag ginagawa to, dapat yung mga maliban sa may mga drain, yung mga manholes na ilalagay, dapat yung mga conduits mas mataas yung portion sa gitna ng dalawang manhole, no? Anong ibig sabihin? Mas mataas ang elevation or yung invert elevation, no? In other words, gagawin mo na yung mga manholes magkabilaan. Kunyari, may manhole ka rito, may manhole ka doon. Yung bandang gitna ng duct bank, mas mataas kesa doon sa lugar ng manhole. Anong ibig sabihin? Para mag-drain, para may slope ng conduits papunta sa mga manholes. So, during flash floods, during strong rains, at posibleng pumasok ang mga tubig sa manholes. Now, because dahil tinaas mo yung gitna mo, ang tendency pag nag-drain ay papunta sa manholes. Hindi yung pag malalim siya, maiipon ang tubig doon sa gitna mo. Okay? So, reminder po yan sa installation ng mga ganitong klaseng open area duct banks. Okay, ganun din sa ganito, sikapin natin na yung slope nito ay papunta dun sa manhole dito kasi mataas ito otherwise kung mababa itong mga lugar na ito, itong portion na ito, maiipunan tayo lagi ng tubig dyan sa portion na yan na kung saan mababa yung duct banks mo. So make sure that where the location of the manholes, no, should be the lower points in a stretch of duct banks. Never na may mas mababa sa portion dito, no? Otherwise yun na maipunan tayo ng tubig dyan. Okay, look at this. Yung electrician na nagkabit nito, imbes na ipadaanin niya sa ilalim, dito niya pinapasok. So makita mo pagka tumulong ulan, siguradong diretso papasok siya sa loob ng panel board. At nandyan siyempre yung mga wirings, yung circuit breakers, mababasa sila. At eventually magkaroon ka ngayon ng leakage to ground or ground fault or short circuit. Yan, ito naman madalas nakakakita tayo ng mga ganito. Itong electric cooperatives ay ganito lang sila mag-wiring, hindi nila inaayos. Dapat man lang sana iayos nila yung mga installation nila ng mga itong metering, no? Residential unit kilowatt hour meters. Okay, ito isang panel board na makita mo ay ang mga breakers na line to neutral ang insulation niya. So makita mo rito pag sa isang inspection ko, nabunot ko itong pagka-terminate dito sa upper breaker nito, no? So tayo pag nag-inspection tayo, chine-check natin yan kung tight ba ang pagka-connect. Otherwise kasi kung ganitong may maluwag, eventually pag nag-operate na yan, mag-iinit ito. At kung mag-iinit ito, may possibility ng localized heating and eventually high resistance point, masusunugan ka ng termination. Ito, makita mo yung paggawa ng electrician ng installation nitong elbow type box, no, ay sa gitna niya pinadaan yung mga tubo niya. Dapat dito at saka doon para maximize yung bending angle or bending radius ng ating wires. Whatever is the size of that wire, the size of the box should be maximized in such a way that the bending radius will be at maximum. Okay. Now here we see a shallow well pump installed, no. So you could see that the wiring is just like flying wirings, no, not using the proper wires or cables or conduits to install it. And then secondly, you would notice that the only protection for the motor is a circuit breaker, no. Now the standard protection is that there should be a magnetic motor controller provided with a thermal overload device or a heater device, so that the overload the motor will be provided with an overload protection. In this kind of installation with only a breaker, chances are, because the full load current of the motor is usually very much smaller, no, if this kind of breaker will not protect the motor against overloading. Okay, so a thermal overload protection must be provided. Okay, lightning protection. You could see here just an artistic rendition of lightning. So when will you provide for a lightning protection? Okay, no matter how shorter your building is, like for example, look at this building here, which lies maybe some 50 meters to, not very far from this other building here. Now, do not say that because you have a shorter or a smaller building, this taller building will act as your protection, because most possibly this taller building has a lightning protection. Or if lightning strikes this building, chances are you will already be protected. That's not the case, because how about if the clouds that produces the lightning is moving from the left side to the right side, no? From here going to this direction. So in other words, the clouds will first be passing by over the shorter building before the taller building is being passed by, no? So therefore, there will be a big chance that lightning could also strike even at the shorter building, because it passes through the shorter building ahead of time. In my example, that the clouds is moving to the right side direction. If the clouds is moving from the right side to the left side, then maybe that would be correct. That means that the taller building in this case would be the first one to be struck with lightning. So what's the suggestion? Well, even if you have a shorter building, you should provide the lightning protection. So with this building, a shorter building near this other building, okay, and some other instances. So a lightning protection system would be best with early streamer type. Now this picture shows a solar farm in Batangas is being provided with lightning protection through the installation of 8 meters high steel poles and early streamer type lightning protection system. No, of course, now where in the Philippine Electrical Code would you be able to find this early streamer type? No, in the code, even the National Electrical Code and the Philippine Electrical Code as well, and other codes in the world, they do not indicate this early streamer type as lightning protection. What is indicated in our codes are the ordinary passive type. No, it's make use of lightning rods installed on the top of the roofs with down conductors. The only code, electrical code in the world that provides for this specification or specifies for this is the French Electrical Code. The French are very advanced in chemistry and chemical technology, and that's the reason why they are much more daring when it comes to specifying this kind of lightning protection system. Yours truly have been involved with many lightning protection design, and I can assure you that this type of protection is much foolproof than the passive type. The passive type can be selective in terms of its protective capability, while this would provide for an umbrella type protection. Umbrella type, meaning to say this kind of protection throws away ions in the air and provides that gap between the clouds that will release the lightning charge. Okay, so here is another schematic that will show you the lightning protection there on top of this rod or pole, and then the ground conductor, no? And lightning rods indicated here down below, no? My suggestion, if it is a residential building, no, is that this ground down conductor, I suggest that it should be we should use insulated cable, no? Maybe even a 600 volts insulated cable will be much better than just simply using a wire conductor inside a PVC conduit. It would be a lot more safe for the people inside the building. Here is the typical counter, lightning charge counter for the early streamer type lightning protection. And this is a slide that shows us a steel structure building where it is very necessary to connect to ground the steel structure through a ground rod. Okay, so here we have a load schedule being prepared. When we do the load schedule, we indicate the wattages per circuit here on the left side here and under watts, and of course the voltage and the computed currents, no? So dividing the wattage of per circuit by the current gives us the current, and therefore will give us would easily let us select the size of wire. So this is 13.91. It's less than 16 amps, so you can use even 2.0 mm or 3.5 mm. And 20 ampere trip is the selected protection. Okay, so and so on and so forth. Now we always have to add in the computation of the main feeder